Are you frustrated with high-power BLDC motors cutting out under load? You're not alone. Many people face this issue, but the solution lies in understanding the details of your motor system. High-power BLDC motors can perform well on the bench, but struggle under real vehicle conditions. When installed in scooters or go-karts, they face challenges that cause cutouts. These include launch torque, battery voltage sag, and controller incompatibilities. Diagnosing issues starts by identifying the type of cutout. Is it instant at startup, or does it occur after prolonged use? Each symptom suggests different underlying problems. For instance, shutdown at startup may indicate high current demand or wiring issues, while cutouts during acceleration often point to voltage sag or thermal shutdown. Understanding load conditions is crucial. In no-load operation, the motor may rotate even with weak components. However, under load, every weak point is exposed. A thorough diagnosis involves monitoring voltage and temperature during operation. Record data about how the controller and motor behave at the moment of cutout. Next, assess the battery and battery management system, or BMS. The battery must provide sufficient current, or the system may trip under demand. Voltage sag and BMS limitations are common causes of cutouts. You should also inspect the controller. Its parameters must match the motor's requirements, including current limits and heat management. Overheating due to poor airflow or excessive demand can lead to shutdowns. Do not overlook the wiring and connections. Poorly crimped connectors increase resistance and generate heat, which can lead to failures. Make sure that Hall sensor and phase wiring align correctly to avoid synchronization issues. Finally, evaluate mechanical loads like gearing and weight. Too tall of a gear ratio can reduce efficiency and increase current draw during launches. Make sure your drivetrain is not overloaded, which could force the system into a cutout condition. To troubleshoot effectively, follow these steps. First, measure battery voltage under load. Second, check BMS current limits against the controller's demands. Third, inspect wiring for defects and proper connections. Fourth, monitor temperatures of the controller, motor, and connectors during operation. Fifth, review mechanical load conditions to make sure everything is aligned for optimal performance. By understanding these factors, you can pinpoint and resolve the underlying causes of motor cutouts, ensuring better performance for your high-power BLDC systems. If you're considering upgrades or replacements, always verify compatibility and request detailed specifications from your suppliers. Ready to optimize your BLDC motor system? Start by implementing these diagnostics to improve performance and reliability.